Something just cracked open in the Linux world, and if you've only skimmed the headlines, you have no idea how big it actually is. This isn't one story. It's 3 separate fault lines running underneath the same platform at the exact same moment, and almost nobody outside a handful of mailing lists and developer forums has connected them yet. KDE is quietly finishing its own full operating system. The Linux kernel just blew past 43 million lines of code on its way to version 7.2. And behind the scenes, some of the most respected names in open source just walked away from their own projects, in public, over conflicts that have almost nothing to do with code. Layer those 3 things on top of each other, and you start to understand why longtime Linux users are calling this one of the strangest, most consequential stretches this platform has been through in years. Here's the part that should genuinely surprise you first, because it's the part almost nobody outside the KDE community has fully clocked yet. KDE isn't just building a desktop anymore, it's building an entire operating system, officially called KDE Linux. And according to the project's own June 2026 development update, it now sits at 78% of the way toward its beta milestone. Read that again. Not a repackaged spin of an existing distro, not a theme. A ground-up operating system with atomic, image-based updates, meaning your entire system updates as one verified block instead of thousands of individual packages quietly stepping on each other's toes. That was the pitch. And back in March 2026, KDE's own developers publicly admitted that pitch didn't hold up the way anyone hoped. According to a development update from KDE's Harold Sitter, a run of updates left several user systems completely unbootable. The supposedly bulletproof atomic system turned out to have a hidden failure mode. A bug buried in a newly released version of System caused one stage of an update to silently fail, while a later stage reported success anyway. And a second separate bug meant that trying to roll back to the last known good state could actually erase critical system files instead of restoring them. This is not chaos. This is strategy revealing its own blind spot in real time. And KDE's team didn't bury the story. They published it themselves, joked openly about their atomic updates turning out not to be so atomic after all, and kept building anyway. That's what makes this genuinely interesting instead of just embarrassing. By the project's June 2026 report, the tone had completely shifted. The team described the month as smooth, with no build delivery drama and every shipped OS image meeting quality standards. They're now finishing an entirely new automated QA system built specifically to catch this exact category of failure before it ever reaches a real user's machine, converting the operating system's raw disk image into a hybrid format that also works as a standard installable ISO, and hardening the underlying kernel configuration used specifically for KDE Linux. Think about what that actually represents. A small experimental operating system built by a team that publicly documented its own worst failure mode, then spent 3 months systematically making sure it can never happen again. That's not a project in crisis. That's a project stress testing itself in full public view, mistakes included, and coming out the other side stronger for it. And while all of that has been unfolding underneath the surface, KDE's actual flagship product, the Plasma Desktop, just had one of its biggest releases in years, arriving on June 16th, 2026. According to KDE's own release notes, Plasma 6.7 finally delivers something users have been requesting since 2005. 21 years? That's how long true per screen virtual desktops sat as an open request before finally shipping. Alongside it came a brand new theming engine called Union, designed to let developers style Plasma and its apps with standard CSS instead of juggling multiple incompatible systems. A one-tap toggle to instantly flip between light and dark global themes, and meaningful Wayland refinements as KDE prepares to drop X11 support entirely in the upcoming Plasma 6.8 release. On the surface, this looks like a routine, healthy release cycle for one of the most widely used desktop environments in the entire Linux ecosystem. And it is that. But it's happening at the exact same moment the kernel sitting underneath every single one of these desktops is going through something far messier and far more revealing about where this whole ecosystem is actually headed. Because right now, underneath every distro, every desktop environment, every KDE release you've ever installed, sits the Linux kernel itself, and it just crossed a genuinely startling technical threshold. On June 28, 2026, Linus Torvalds released the first release candidate for kernel version 7.2 and confirmed directly in his own announcement on the kernel mailing list, the source tree now contains more than 43 million total lines, specifically 43,179,595 by a raw count, or roughly 42.58 million, once you strip out comments and blank space using language-aware tooling. For comparison, the previous stable release, Linux 7.1, sat at just over 42.6 million lines. That's a jump of roughly 563,000 lines, about 1.3%, in a single 2-week merge window. A third of that increase, according to Torvalds himself, is nothing but raw AMD GPU register definitions. Even stripping those out entirely, driver code still makes up more than half of everything added. This is a kernel running everything from Raspberry Pis to hyperscale server racks, and it's still growing every single cycle without slowing down. And that's exactly where the real question underneath this entire story starts to surface. If the code is growing this fast, and the desktop sitting on top of it just shipped features people waited 2 decades for, why are some of the most important people behind Linux suddenly, publicly walking away from the projects they built their careers on? Here's where the story stops being about code entirely and starts being about people. Because in this same stretch of 2026, while KDE was shipping its biggest desktop release in years, and the kernel was crossing 43 million lines, 2 of open source's most respected maintainers publicly resigned from their own projects. And the reasons behind those 2 resignations have split the Linux community right down the middle. The first one hit hardest because of who it came from. Hector Martin, founder and lead developer of Asahi Linux, the project responsible for bringing genuine Linux support to Apple Silicon Macs, announced he was stepping down as project lead, effective immediately, according to a detailed breakdown of the situation from Twitey's Untitled Linux show. In his own words, Martin said the project had become less fun over time, pointing specifically to mounting user frustration over incomplete support for newer M3 and M4 chips, and features that still hadn't landed years into the project's life. Sit with that for a second. This isn't a project that ran out of funding or lost relevance. Asahi Linux is one of the most celebrated reverse engineering achievements in modern open source, turning locked down Apple hardware into fully functional Linux machines from scratch, and its own founder walked away, citing exhaustion dressed up as declining enjoyment, a pattern that anyone who has ever led a volunteer-driven project will recognize instantly. The good news is the project itself isn't ending. Leadership passed to co-maintainer Sven Peter and developer Jana Grunau, who's been working on the project's downstream kernel since April 2026. Asahi Linux continues. Its founder simply isn't the one steering it anymore. The second resignation is the one that actually detonated across forums and social media. Because it wasn't about burnout at all. It was about a single sentence. Carol Herbst, maintainer of the Nouveau driver, the open source graphics driver, project for NVIDIA hardware, stepped down after another maintainer used the phrase, "We are the thin blue line," during a kernel development discussion, as detailed in the same Twitey community breakdown. That specific phrase, commonly tied to pro-police messaging in the United States, landed completely differently depending entirely on who was reading it and where they were reading it from. As one host put it, while trying to explain the disconnect to a genuinely global audience, in some regions the phrase barely registers as political at all, while in others it reads as openly charged. Connect to a genuinely global audience, in some language evolves, as one commentator on the discussion pointed out, and phrases that meant nothing to someone in their youth can quietly become loaded over time without the speaker ever intending it that way. The hosts, covering the fallout, landed on an uncomfortable conclusion for a community built entirely on remote international collaboration, pushing someone out of. A project purely over a single political phrase, with no larger pattern of behavior behind it, sets a genuinely dangerous precedent, no matter which side of the phrase you personally land on. And yet, the resignation happened anyway. As with Asahi Linux, there's real structural resilience here. Nouveau still has 2 remaining kernel maintainers, and development is already underway on Nova, a planned rewrite intended to eventually replace Nouveau altogether. But both of these resignations are really just visible symptoms of a much larger, slower-burning conflict that's been simmering across the entire kernel community for well over a year, the fight over Rust. Since 2022, the Linux kernel has been slowly opening its doors to Rust, a modern programming language built around memory safety, as a supplement to the kernel's traditional, decades-old C codebase. That supplement has caused genuine, sustained friction ever since. The core tension is easy to state and brutally hard to resolve. Rust's entire selling point is preventing the exact kind of memory safety bugs that have haunted C code for 50 years. But introducing it means asking veteran maintainers, people who've personally reviewed tens of thousands of patches over their careers, to accept new tooling, new review overhead, and entirely new failure modes they never signed up for. Christoph Hellwig, the kernel's DMA subsystem maintainer, became the public face of that resistance, rejecting Rust-related patches even when, as Linus Torvalds himself pointed out in a widely circulated public reply, those patches didn't touch Hellwig's own subsystem code in any way. Torvalds' response was blunt. A maintainer can either actively engage with Rust bindings touching their area or step back, and let them exist as an independent, complementary user of their code. But what a maintainer cannot do is veto Rust code simply because it happens to exist nearby. The fact is, Torvalds wrote, the pull request you objected to did not touch the DMA layer at all. Hector Martin, before his resignation, had publicly urged the Rust for Linux team to keep pushing forward regardless, warning in sharper terms that no amount of resistance from what he called entrenched maintainers was going to reverse the broader industry's shift toward memory-safe languages. Miguel Ojeda, the developer most closely associated with the Rust for Linux effort, has since published a formal Rust kernel policy specifically designed to prevent future blowups like this one, clarifying that Rust for Linux isn't an official initiative of the Rust Foundation itself, and that a significant number of core kernel maintainers do actively support its presence in the tree. So layer all three of these together for a second, because this is where the picture actually comes into focus. A beloved reverse engineering project loses its founder to simple accumulated exhaustion. A graphics driver loses its maintainer over 7 words that mean something entirely different depending on which country you happen to be reading them from. And underneath both of those very public departures sits a 4-year language war that's been quietly reshaping how kernel maintainers relate to their own code the entire time. None of this is happening in isolation, and right now it's colliding with something else entirely, a brand new category of contributor that kernel maintainers have never had to deal with before, one that's testing the community's patience in a way nobody fully anticipated. Here's the part of this story that genuinely surprised me while digging through it, because it isn't maintainers fighting maintainers anymore. It's maintainers fighting a flood of code and a flood of bug reports, generated by tools that barely existed in any serious form a few years ago. Back in April 2026, a developer submitted a clean, properly formatted patch to the Linux kernel, complete with a reasonable commit message, the kind of submission that would normally move through review without much friction at all, according to a widely discussed account that later spread across Hacker News. The maintainers rejected it anyway, not because it contained a bug, because they suspected it had been written by AI and they weren't willing to spend their limited review time untangling code from a system that, in their own experience, tends to sound most confident exactly where it's most dangerous. Here's the underlying problem, and it's worth sitting with. Every experienced kernel maintainer carries a kind of mental pattern library built over decades, a catalog of exactly how human beings screw things up. Off by 1 errors, forgotten lock releases, a missing null check after allocation. After tens of thousands of patch reviews, that library becomes a genuine radar system. AI-generated code doesn't trip that radar the same way because its mistakes aren't shaped like human mistakes. They're novel, unfamiliar failure modes hiding inside code that reads as clean and well-formatted, which, if anything, makes them harder to catch, not easier. And this wasn't a one-off incident that quietly went away. It became a defining friction point of the entire Linux 7.1 release cycle. According to detailed coverage of the Linux 7.1 release, which shipped on June 14, 2026, Linus, Torvalds himself expressed open frustration during that cycle about the sheer volume of AI-generated bug reports flooding in. Many of them effectively duplicates, produced by different people running the same automated tools against the same codebase and submitting near-identical findings as if each were an original discovery. Torvalds' message to the community was direct. Read the documentation, actually understand what you're reporting, and if you're going to lean on these tools, pair them with a genuine fix, not just an automated alert dumped into an already overloaded inbox. It's a strange, distinctly 2026 kind of maintainer burden. Not malicious contributions, not incompetent ones. Just an overwhelming volume of technically plausible noise that still has to be individually triaged by human beings whose time is the single scarcest resource in the entire project. Now here's where all 3 of these threads actually land, in the kernel itself, right now in the summer of 2026. Linux kernel 7.1 shipped on June 14th with nearly 13,000 individual changes contributed by more than 2,000 developers, over 300 of whom were contributing for the very first time, according to detailed release coverage from OS Technics. That release made Intel's flexible return and event delivery, known as FRED, the default handling mechanism for certain system transitions, introduced a completely new in-kernel NTFS implementation, and, notably, stripped out support for Intel's ancient 486-era processors entirely, alongside more than 140,000 lines of other obsolete legacy code. 2 weeks. Later, on June 28, 2026, Torvalds opened the very first release candidate for Linux 7.2, and this is where the numbers start to feel almost absurd. The kernel source tree crossed 43,179,595 total lines by a raw count. Roughly 42.58 million of those lines qualify as actual language-aware code once you strip out comments and blank space, according to independent analysis published by OS Technics. Put the growth in context. Linux 7.1 sat at roughly 42.6 million lines. In a single 2-week merge window, the kernel grew by about 563,000 lines, roughly 1.3%, pulled from patches submitted by more than 200 subsystem maintainers. And yes, a full third of that growth is nothing, more dramatic than raw AMD GPU register definitions, the tedious hardware description tables new graphics chips required just to function. But even stripping those out completely, driver code still makes up more than half of everything added in the cycle. This is the tension that defines the modern Linux kernel in a single sentence. It keeps growing at a genuinely startling pace while its maintainers simultaneously fight to remove anything obsolete, filter out an unprecedented flood of AI-assisted noise, and hold together a global, unpaid, volunteer-run review culture that was never designed to operate at this scale or this speed. Following its usual pattern, the 7.2 kernel is expected to move through roughly 7 to 8 weekly release candidates before landing as a stable release sometime between August 16th and August 23rd, 2026, according to 9to5Linux's own reporting, based directly on Torvalds' established release cadence. Torvalds himself described the opening of this cycle as reasonably normal, a phrase that, given everything else happening around it at the same time, is almost funny in context. Think about what's actually sitting on the table at the same moment here. A kernel physically bigger than it has ever been in its 34-year history. A maintainer community that just watched 2 respected names walk away over conflicts that had nothing to do with technical competence. And a brand new category of low-quality, AI-shaped contribution volume that nobody built a review process for, because 5 years ago it simply didn't exist as a problem. None of these 3 things caused the others. But all 3 are happening to the same small, overworked group of human maintainers at the same time, underneath every desktop, every phone, and every server currently running this software. And that's exactly what makes the next question worth asking directly. Does any of this actually threaten Linux's stability? Or is this simply what healthy, high-velocity growth looks like from the inside, messy in the moment and completely fine in hindsight? So step back and look at everything sitting on the table right now in the middle of 2026, because none of it is actually separate. It's one story, told from 3 different angles, and it points toward the same underlying truth about where Linux is actually headed. KDE is building its own operating system in full public view, and it already survived a serious, genuinely embarrassing failure. Systems left completely unbootable, caused by a hidden interaction between a newly released version of System and KDE Linux's own atomic update mechanism. Instead of quietly burying that failure, the team documented it themselves, root caused it publicly, and kept shipping anyway. As of the project's own June 2026 report, KDE Linux now sits at 78% toward its beta milestone, with a new automated QA system nearly ready to catch exactly this category of failure before it ever reaches a real user's machine again. At the same time, KDE's flagship desktop, Plasma, just delivered features people had been requesting since 2005. 21 years of patience finally paying off in a single release cycle. That's not a project quietly declining. That's a project stress testing itself in public and coming out stronger for it, one hard lesson at a time. But underneath that desktop sits a kernel going through something far less comfortable. 2 respected maintainers, Hector Martin from Asahi Linux and Carol Herbst from Nouveau, walked away from their own projects within the same general window of 2026, one from accumulated exhaustion, the other from a single 7-word phrase that meant something entirely different depending on which country you happened to be reading it from. Neither project collapsed. Asahi Linux continues under new leadership. Nouveau still has active maintainers, and Nova is already being built as its eventual successor. But both resignations are visible symptoms of a much larger, ongoing fight over Rust's place inside a 50-year-old, C-dominated codebase, a fight serious enough that Linus Torvalds himself has had to step in personally and draw explicit lines around what a maintainer can and cannot veto. And now, layered on top of all of that, is something genuinely new, an unprecedented wave of AI-generated code and AI-generated bug reports that doesn't trip the mental pattern library kernel maintainers have spent decades building to catch human mistakes, forcing Torvalds to publicly ask contributors to slow down, actually read the documentation, and stop flooding an already overloaded review pipeline with duplicate, low-effort automated noise. Meanwhile, the kernel itself keeps growing anyway, now sitting at more than 43 million lines, as of the Linux 7.2 release candidate on June 28th, 2026, with a final stable release, expected sometime between August 16th and August 23rd. New hardware support keeps pouring in every single cycle. Obsolete code keeps getting stripped out just as fast. More than 2,000 developers, over 300 of them brand new to the project, contributed to the most recent stable release alone. This is a project that is simultaneously larger, faster growing, and more actively maintained than at any point in its history, while also visibly straining under interpersonal conflict and a flood of low-quality automated contributions that simply didn't exist as a problem 5 years ago. Here's why this actually matters to you, even if you've never compiled a kernel or opened a KDE settings menu in your life. Linux quietly runs the overwhelming majority of the world's cloud servers, every single Android phone, and a growing share of desktops for people migrating away from Windows 11's more restrictive hardware requirements and increasingly Copilot-driven direction. Every thread running through this story, KDE's new operating system stabilizing, in public after a real failure, respected maintainers walking away over unresolved cultural fault lines, a kernel ballooning in size while fighting off an AI-shaped flood of noise, feeds directly into whether the software quietly running underneath your phone, your router, your favorite streaming service, and increasingly your own desktop stays healthy, secure, and actively maintained for the next decade. This isn't some abstract developer squabble happening far away from your life. It's the operating system layer of the modern internet, visibly working through real growing pains in real time and doing almost all of it in public, which, frankly, is more transparency than most closed source platforms have ever offered you. So here's where all of this actually leaves things heading into the second half of 2026. KDE Linux is closing in on its beta milestone, with a hardened QA system nearly finished and a hybrid ISO format already built to make testing dramatically easier for anyone curious enough to try it. Plasma 6.8 is already being planned, with KWin set to drop. Desktop OpenGL support entirely as the project pushes further into a Wayland-only future. Linux kernel 7.2 is working through its release candidate cycle right now, with a stable release landing in late August, and kernel 7.3 already quietly forming behind it. And the human side of this story, the maintainer, resignations, the ongoing Rust policy, debates, the AI contribution flood, isn't resolved. It's still ongoing, still messy, and if the last 18 months of Linux development are any indication, it's likely to produce at least one more headline-grabbing flashpoint before the year's out. If you've made it this far, you clearly care about where this platform is actually headed, not just the surface level. Release notes everyone else is copying and pasting, so subscribe, because the Linux 7.2 stable release, KDE Linux's beta launch, and whatever comes next in the Rust and maintainer story are all landing within the next couple of months, and you'll want to be here when they do. Drop a comment and tell me honestly, does KDE building its own full operating system on top of its desktop and app suite excite you, or does it worry you that the project is stretching itself too thin across 3 massive commitments at once? I'll be reading every single reply.